So my name is Jennifer Mankoff. I am a faculty member in the Human-Computer Interaction Institute. And my research is really diverse, but right now the majority of it is focused on a combination of 3D printing and data mining in the domain of accessibility primarily. And the very first time I built a visualization was probably as an undergraduate working on my honors thesis, thinking about making the internal workings of the programs I was writing visible in order to support debugging. And it's for that reason that the title of my talk today is Challenges in Making the Hidden Visible, because for me, information visualization, its real purpose is to help us uncover things that are not already obvious to us, right? Often based on data that we can't necessarily see. And I'm talking here particularly about information visualization, although I think scientific visualization also has this property. So I've always been really passionate about that. And in fact, I even teach a course in the spring where we talk about a variety of topics in data science, really centered around the human role in all of that. So the course is called Interactive Data Science for that reason. And to me, you can't really study visualization if you also don't think about some of the things that lead up to having a good visualization. So today we're actually going to cover sort of a survey of some of the things that I talk about in my spring course with a focus on visualization, but also thinking about how do we make sure we have the right data, how do we make sure that we understand it properly, how do we make it comprehensible to the people who are viewing the visualization, all of those pieces. So I guess I want to start by going back to my original motivation, which is that, having access to new information, ideally, why do we do that, right? This is an artificial science. We do it for people. And so the question is, how can access to this kind of information change how people act in the world? And here you see an example of an application that's intended to encourage green transportation behavior or other kinds of green behavior as just one example. So one place we use visualization then is for behavior change, right? But there's many other examples of how we use it, especially in interactive settings. And in fact, I would argue that information for and about people is a sort of prosthetic that can enhance what we're capable of or change what we do. It can motivate us. It can actually influence the balance of power between different peoples. And you see this in citizen science. It can allow us to educate ourselves. It can support policy, politics, all sorts of things, right? So ultimately, it can support business. Ultimately, if we're showing information to people, presumably we have one of these kinds of goals in mind. And I'm going to argue later that understanding the goals of what we're doing is really critical to building the right visualization. So the hierarchy that I want to sort of propose for thinking about this is that we have data as a first step, right? And we have to collect and interpret that. And you could think about like the speedometer on your car is just giving you raw data. But then if we want to turn that into information, which is the first step towards visualization, then we have to start doing some sense making. And so an example would be when you're driving down the road and instead of just seeing your speed, you see it juxtaposed next to a highway sign that is helping you think about what does it mean that I'm going 29 miles an hour? Is it a good thing? Is it a bad thing? In this case, it's a little bit fast, right? And then you can go even further. You can think about knowledge and generating knowledge from data. And I think a lot of what you study in this course has to do with these kinds of things, right? The ways in which we can use machine learning to interpret data. And so knowledge is where we're beginning to maybe support motivating people, changing behavior, acting on data, all of those kinds of things. And I think both the information and the knowledge phases of data interpretation are opportunities for visualization. So as I said earlier, I'm not going to start this lecture with visualization because I think that you can't really discuss visualization if you haven't thought about what it is you're trying to visualize. And before you can get very far down that road, you have to ask yourself if you have even gotten the right information in order to create the visualization that you want to create. So how much have you talked about this in Zico's class? Have you talked about what it means to sort of collect the right data that's appropriate to the question you're trying to answer? Have you talked about bias in data collection or problems with data? Is that a topic you've gone over much? I see nods and head shakes. What's that? Not as much bias. Okay, so we'll talk about that a little bit. And so one of the things that I think is really important to consider is whether you can trust your data. And this was a really interesting study that came out not that long ago. And I don't know how well you can see it from there, but what it says is large amounts of student debt are not common. Only 7% of young adult households with student debt have more than $50,000 in such debt. And then this is a bar chart, a visualization, right, showing the amount of debt, the number of people who have different amounts of debt. And the vast majority in this bar chart have less than 10,000. Now, you might not be able to see it very clearly, but the actual chart had a subtext that said, based on households with people between 20 and 40 years old with at least some education debt, which is a little bit of a fudge, right? Because these are not households actually with people between 20 and 40. They're households headed by people between 20 and 40, which is to say this excludes everyone who's living at home, for example, right? And you might think about whether somebody living at home versus living independently is likely to have more or less debt. Also, it includes college graduates from almost 20 years ago, when the amount of debt that was typical was much lower than it is today. And they divided the amount of debt by the number of people in the household, if you dig into what they did with the data analysis, which further changes the outcome, right, in interesting ways. So one person's $20,000 college debt becomes two people's $10,000 college debt, for example, right? They also set aside about a third of the people in their original sample because they weren't paying off their debt, which is a little bit strange as well, right? If you have debt but you're not yet paying it off, why would that not be counted in this survey? So this was a really interesting visualization to see what was put out there versus the reality of the study. And there was a lot of sort of weblog sort of analysis of it. It also lacks history. So it lacks information about the fact that student debt has doubled over the last 2 decades. And so this got picked up, I believe, even in the New York Times, and then in the blogosphere. And there's some really great, in the slides, you can click on this if you want to see a more detailed analysis of why you might or might not believe that this visualization is telling the story that the data is actually telling. So that hopefully motivates my wish to get you thinking first about what questions you're asking and how you're using your data to answer them, and second about whether you use a bar chart or some other kind of visualization. And I think one of the sort of most important things to realize is that the plural of anecdote is not data, on the one hand, and that just because you have a lot of data on the other doesn't mean it's good data or it's answering the question you think it's answering. So good data with respect to what you care about. So let's talk about some sources of error in understanding data. One of the biggest things that can happen is sampling errors, and particularly systematic bias in sampling, and we'll talk about that in a moment. And there's also a way in which the very act of collecting data can cause bias. And here we're talking particularly about survey data or other situations where people are reporting things. And then, of course, there can be errors that accumulate as data is being entered or processed. So these are all things that you have to consider when you're first taking a new data set and looking at whether it is the right data for the story you want to tell. So here's an example, a really interesting story about what makes a good sample. So here you can see 4 different possible samples, actually 3 possible samples and a population distribution. And this is from a study on evidence-based medicine that is arguing why several of these samples are not very representative of how effective a medication is. So sample 1 is centered at the same average as the true population. If we took a sample like that from this population and studied how they reacted to a medication, would you trust the results? Why or why not? Talk to your neighbor for a second and see if you can come up with an answer. For sample 1, sample 2, and sample 3, which one do you trust best and why? I don't hear talking. You can sit closer together. You can also introduce yourself if you want.
Like almost all the rest of them. So the sample one does not cover
Does anyone have an answer for me? So let's start with sample 2, or sample 1. Is sample 1 a good sample? Raise your hand if you think sample 1 is a good sample. Why are you not raising your hands? Yes?
Firstly, lies on the mean of the population, and it can be compared to the population as well. So, as compared to other samples, it's more closer to the mean.
Right, so it's closer to the mean. Do you want to add to that?
Well, I just thought it seems a little symmetrical with respect to the population distribution. I mean, the mean and I don't know how to find my.
The standard deviation?
Yeah, it looks like it could be a small representation.
So it has the most similar shape to the original distribution. That's correct. What I think is important about sample 1 is that it fails to capture the true diversity of the distribution. And so if you're thinking about Medicaid, I mean, you guys are both right about how well it resembles that distribution. And there's, even with sample 3, where you have a different kind of number of people sampled for different parts of the distribution, there's other issues that come up. But in this case, if you want to know whether the medicine works really well for people who are unusual, sample 1 won't tell you. Sample 2, of course, is missing all sorts of things, right? It's obvious that that sample is wrong. If I had a preference, I'd be looking for a study with sample 3 in the case of understanding medication's impact. Not necessarily the typical sample in a medical paper, though. So that's just sort of a beginning of getting you thinking at how do you even make these decisions. It might depend on what you're trying to accomplish with the medication, right? If you're worried about the safety of the medication, it might be particularly important to have people on the edges of the distribution. If you just want to know, if you're doing a marketing study where you want to know are the people most likely to buy the medicine going to like it, you might prefer to have something that looks more like sample 1. So it's not the case that there's a black and white answer for these kinds of questions, and that's why you may have struggled with trying to decide which sample you liked. So I'm really just doing a survey here. Again, I can go into more depth if I have a whole semester with you, but I want to give you a feel for some of the kinds of things you should be asking about your data. So the next thing I want to talk about is bias during data collection, and particularly demand characteristics, which are an example of a bias that's generated by the person who's providing the data's thoughts about what you are looking for, where they form an interpretation of an experiment's purpose. There are many other kinds of bias that can come up in sampling, and what we saw earlier was also an example, but this is a fun one. So here's a video that illustrates this. Anyone know how I get? Here we go.
People outside to check out the new iPhone 5, which is unavailable so far. So in reality, what they were looking at is the current iPhone 4S that everyone has. And well, here's how that experiment played out.
The new iPhone 5 just came out today. We want to know if you'll take a look at it. Tell us how it compares to the last iPhone.
I'd love to. Oh, it's way better. That's nice. That's definitely noticeably better.
It's a little thinner. Looks like the screen's a little bigger.
Seems a little bit faster.
Yeah. Faster, lighter.
Feels heavier.
Feels heavier?
I think so. A lot lighter than the last one. It's a lot faster as well.
Mine's gonna take forever.
So this one's faster?
Yeah, definitely faster. Right on.
Oh, it looks very nice, very updated.
Oh my god, it feels a lot lighter and just more, just a lot high quality. It's got, if you drop it, it looks like it's not gonna break. Like this one has a million times. The screen is clear, HD. Colors are brighter. Oh, it has a video running back? Video running back? That's cool. That doesn't have that.
So you like it better than the last one?
Yeah, I have the 4S.
Yeah?
Yeah. I'm always open for a new phone.
what's going on there is this impact that collecting data can have on the actual data you get. And it's much more common when we're collecting from people, right? If you put a sensor out in the world, for example, you might not have the same impact, but you certainly have to think about bias even in sensor data. So there's I don't know how true it is, but an opinion out there in the climate change world, for example, that if all of the sensors that were measuring temperature were not in parking lots, right, that they would be showing a wider variety of cooler temperatures than we get if they are in parking lots. Well, so that can be tested. Are they really a biased sample? Parking lots are an easy place to install these. Maybe there are more of them in parking lots, maybe not. But where you choose to place a sensor can certainly impact what the quality of the data is that you get out. Similarly, if you're trying to, I don't know, sense things with a mobile phone, if people have habits of when they carry their phone and when they don't, and when they turn it off and when they leave it on, you might be getting a biased picture of how they spend their day. So there's all different sorts of ways that bias can come up. But I like pointing this one out because it's unexpected, right? That this idea that people would just totally perceive the world differently than you expect, partly through the data sampling process. And so we can see response bias actually comes up frequently in studies where we're asking people questions. And there are ways of addressing it if you're trying to get data about a system. You might think about, for example, what would happen if Google said, we're trying to test whether or not people like this new version of the interface better explicitly, or if they just subtly take 1% of their users and change it and then look at the behavior, right? So those kinds of differences can be where you'll see this pop up in a larger scale setting. Please interrupt me if there's any questions. So another thing that you have to consider is measurement errors. Badly designing questions or sensor, badly choosing the wrong sensor to get the information that you want to get. Bad administration of a measurement instrument or bad placement of a sensor, and inaccurate measurements are all places this can come out. And then finally, we can see errors occurring in data entry and processing. And there's all sorts of ways this can play out, you know, from a form that if a human's doing any translation of the data to an algorithmic error in which you accidentally zero out some part of your data set without realizing it, right? There's all sorts of places where those kinds of errors can come up too. So the way that I like to work with my students to identify these kinds of issues is by asking these 4 questions about any data set before you start significant analysis with it. Is it complete? So with respect to the problem you're trying to solve, is it missing information? Is it missing information in a biased or unbiased fashion? Many of the data sets we have, you have to impute pieces of them. It's not uncommon for things to be incomplete, but you have to understand what that is. Another really important question is whether it's coherent. So does it make sense with respect to itself? Are you seeing strange things in the data where it seems as though everything has a 0 value at a certain time of day that doesn't make sense? Those kinds of issues. A third question you need to ask is it correct? A really common kind of error that you see in data sets is that maybe there's more than 24 hours in the day because of the way in which the midnight hour is handled. If something starts before midnight and it goes past midnight. So you can look for those kinds of errors as well. And then the last thing I always like to emphasize when considering whether data is ready for visualization is whether you know its provenance. Do you know where it came from? How much faith do you have in the people who produced it if it was not yourself? And so this is what we call accountability. So those are sort of the 4 C's that I try to tackle before I dive into visualization. So again, completeness has to do with how appropriate the data is. Does it match the question you want to answer? Is it missing? Is there some kind of incorrect information coming in? With coherence, we're really looking at whether the data adds up and makes sense relative to itself. Another issue with coherence I didn't mention is extreme values. But you could also look for like a non-number in a number field. It's very frequent with zip code data, especially if it's hand entered, that you'll see zip codes that have 4 digits or 6 digits, right? That's an issue with coherence in the data. It's also an error. An email that has no @ all of these kinds of things are things you have to look for. With correctness, I often try to itemize aspects of the data that are easy to verify and even look for complementary data like a survey or some sort of US report and see whether my measurements and the things I would expect to see in the data match what really happened. And so I also at that stage of my analysis look for sources of bias within the population across variables, and I try to dig into whether I can trust this data and whether any of it is bad. Okay, so that's really all I want to say about collecting data. The next stage of what I want to talk about has to do with how we make sense of it. And because I tend to take a human-centered approach to this, and because we're talking about presenting data to people, I really like to think about this in terms of things people care about. So often we use data to try to detect activities, what people are doing in the world, right? Whether it's so that a robot can maneuver, or so that we can make a prediction about what advertisement to show on a website, or whether we want to build an application that helps motivate people. All of those require us detecting activity at some level. And I will argue that beyond activity, it's also important to detect routines, and sometimes that's a better substitute than activity. Following that, we might want to know what people's intent is, right? If you knew what people were trying to accomplish when they're doing something, imagine how well you could target things at them that you wanted to accomplish, right? I will argue that's almost impossible. And then related to intent, we also care a lot about causality. Often when we use a visualization, what we're really trying to do is to determine whether the world is a certain way and why. And so these are all things that you might think about, again, in preparing, making sense of data in preparation for visualization. So we'll talk a little bit about each of them. So first, activities. Here, I'm not going to go into how you might recognize activity, because that's really where the other parts of this course perhaps come in, and other classes. But I do want to show how visualization of activity might be used, because I'm trying to really bring the material we're talking about back to visualization as often as I can here. So these are examples of systems that all visualize activity at some level. The one with the butterfly on it is called UbiFit. And so what's being shown here is the level of activity you've had all week, as well as your friends. So they're playing around here with a social kind of visualization and with something that's engaging. And one of the really important things about this visualization that goes beyond the surface level design is that they installed it on the phone so that it was the screen that you would see whenever you turned your phone on. And this had the effect of causing people to put their eyes on the visualization many times a day. How many times a day do you pick your phone up and look at whether you have a message or something like that? And it was much more effective at engaging people in the behavior change they were trying to achieve than if it had been something they'd have to remember and click through. So again, I think, I just want to reemphasize that the message of this whole talk is really that visualization is only part of the design of visualization, right? The thing that you think about first is only part of what makes visualization successful. Whether they chose a bar chart or not probably did have an impact on people, but a far more impactful choice was where they showed it and how often people saw it. So a lot of these examples are quite playful, and that's one of the other things I want to emphasize, and we'll talk more about as we go further into the design of the visual aspect of visualizations, is that it's really important to think of this as storytelling, as a form of narrative design almost, and it's not typically the case that you just want to throw bars at people without thinking about how they will read them. What kind of visual query are you trying to support? And so, in a sense, I would argue that the butterfly visualization at a glance might actually convey more of the crucial information people want than the bar chart, unless they have taken the time to really learn what the bar chart means. It's maybe more accessible. So another thing we can do is try to understand routines. And to me, this builds on activity. If we can understand routines, we can also take action for people in really useful ways. And I want to show this 3 different visualizations of routines that I think help to illustrate this. So this is a visualization of the routines of very creative people with respect to hours of the day. So the blue is sleep, red is creative work, yellow is leisure, green is the day job if they had one, dark blue is exercise. So, and the kind of people you're seeing here on the left are sort of historical figures that are seen as very creative. So it's interesting to compare what they do to what we do. And I think what this visualization really emphasizes to me is the fact that when it comes to creative work, the time of day at which that takes place is really variable for different people who are creative, right? It's not all in a uniform kind of time. Some of it takes place in the middle of the night. Some of it takes place in the middle of the day. it gives you a different perspective maybe on where you fit into that bigger picture if you also do this kind of work. Another way we might visualize routines is more like a diagram of the processes that people go through in executing routines. And this is a visualization generated by one of my students, Nikola Banovic, which was exploring not only the common routines, but the deviations, the common alternatives to routines that one takes. And we iterated on this. I'm going to start showing more iterations of visualizations as we go through this talk. And so one of the things we were trying to figure out was how to make it visually salient what kinds of features of these routines were predictive of you doing something very common versus something less common. Now, this visualization is not designed for a person who's never seen it before to walk up to it and interpret it very well. It is effective at supporting the kind of social scientists who might previously have worked laboriously through qualitative data in drawing conclusions over large quantitative data sets. An alternative visualization that we developed over the same data set, which was really aimed at novices, was something that was really focused on a very different goal, not of understanding what. So the data set I should mention that we were working with was aggressive and novice drivers going through intersections and trying to look at the differences between the behaviors of different kinds of drivers. So with this visualization, domain experts were able to draw conclusions about the typical habits of different kinds of drivers. With this visualization, we were able to influence the attitudes of drivers themselves by showing them their own driving and then showing them those same driving actions aligned with a driver who was less aggressive. So we were able to identify aggressive driving instances, extract them, and then show them in comparison to a simulation derived from the same routine model that we generated, illustrating the differences between how an aggressive and a non-aggressive driver would do the same type of action. And this really had an impact on how people thought about aggressive driving. So those are two very extremely different visualizations, which were both very successful and both based on exactly the same model and data set. And it illustrates the importance of thinking about the goals of the visualization and the context in which it's being used in order to have the correct visualization. Are there any questions so far? Okay, the last thing I want to talk about before we get into visual design is causality. Because I think that whether we explicitly design our visualizations thinking about causality or not, when somebody looks at a visualization, that's often what they're trying to derive from it. I think we're sort of hardwired as people to draw conclusions about things, right? It's sort of a natural thing that we do all the time. It's really what's behind the way in which people jump to conclusions, right? Or even act with bias, partly, is this habit of sort of generalizing from a small amount of data to draw conclusions about the world at large. And so if we are feeding into that habit, we are potentially causing people to draw invalid conclusions, and that's dangerous. So I think it's really important to think about causality and what is possible to conclude from data and what's not. So an example of sort of the kind of thing people typically do, maybe they hear a noise, based on past experience, they come up with a hypothesis, maybe go to a window and verify that what happened is really what's going on, and then they might see something different outside, and so then they see that the prediction is false. And so this is really important because it's only with empirical evidence that we can make and test predictions. And people tend to take visualizations as being empirical evidence, and a badly designed one, as we saw with the student debt, can lead to conclusions that might be false. So one of the things to realize is that there's, or that I think is really important to consider when designing visualizations, is that there's different ways, different pathways by which we draw conclusions. So there's scientific knowledge, right? And from that knowledge may be supported by empirical observation, in which we collect and analyze a lot of data to test hypotheses. But it's also supported by reason and intuition. And so when you come up with new ideas, often it's that reasoning and that intuition that leads to them. And so you might think of reason and intuition as being sort of a Bayesian approach to drawing conclusions versus collecting data as being more of a statistical inferencing process, okay? Now, both of these can have error. So you can have a logical error if you take a Bayesian approach. And you can have a systematic error, such as one caused by bias, if you take a statistical approach. So watching out for when you're drawing, what kinds of conclusions a visualization is suggesting, and whether or not they are appropriate to draw from this data, you have to think about both of these types of reasoning. And an example of this, of a kind of statistically derived error that people often make, is confusing correlation and causation. Have you talked about this at all in class? No? Yes? Maybe? Some? So there is actually a 91% correlation between ice cream consumption and drowning deaths. Percent is the wrong word for that. There's a 0.91 correlation. So here's a question for you. Does eating ice cream cause drowning? So why is this correlation there? There's a good reason for it. It's more than a coincidence. Yes? That's right. So there's a shared causal variable that affects both things. And that's why they're synced. And that's often there can be a hidden shared causal variable. So the things that can go wrong in determining causation is we might have the direction of the arrow wrong, but we might also be missing some kind of additional relationship that's not captured by the data that we're representing. Both of those are important to think about. Here's another example, global temperatures versus number of pirates. So does piracy cause global warming? So again, there's a lot of ways to dig into this, but the important thing to realize is that when you throw up a chart like this, somebody who's not thinking about the data as much as you might come to conclusions that don't entirely make sense, right? I like this summary of the issue. So it says, I used to think correlation implied causation. Then I took a statistics class. Now I don't. Sounds like the class helped. Well, maybe. So this is about the direction of the arrow, right? Okay, so that's kind of all I'm going to say about sense making. What I want to turn to now is what I was ostensibly going to spend the whole lecture on, but I think we now have a groundwork for beginning to understand why and what I'm going to say in this piece of it. Information visualization. This beautiful hand-drawn visualization is from a series of postcards that two women sent to each other once a month for a whole year. And what was being visualized in this particular thing was privacy. And so she tracked everything she did, thought, or reflected upon that she wouldn't want to tell in chronological order by hand, and then visualized it by hand. And what's interesting about what she did, so the bars that you saw at top are, depending on the color, or something she thought or did or whatever. And then the lines down are sort of the degree to which she was ashamed about them. And what I want to highlight here actually is the difference between that visualization and this one. So they each collected the same data for a month. They each came up with their own visualization, and then they shipped it across the ocean to each other. And they have now a book that's come out. It's a beautiful series of postcards. So this person is also visualizing the same data. So these are moments she wants to keep private, and the color shows what type of moment it was, a thought, an action, and so on. And depending on the sort of size of the radius around it, it's like how willing would she be to share it if she had to. And they're ordered by how embarrassed she is. So they came up with similar ideas. To me, this second visualization is so much more evocative of privacy than the first one. Aesthetically, it's more, somehow it captures the concept as well as demonstrating the data. They're both very skilled at visualization, and although I'm critiquing one versus the other here, there's many instances where they're both, equally beautiful, or the other one is better. But I think what I'm trying to get at is the sort of subtle way in which choices that you make about how to show something can really influence the sort of gut feeling you have about what you're seeing and what it means. So I highly recommend, it's called Dear Data. It's a great book. I highly recommend it. But it doesn't really tell you how to visualize, and I think it's very hard to do that because I could give you all sorts of information about how easy it is to differentiate one thing versus another, but none of it would capture the difference between these two charts, which I think is really important to look at. So what is information visualization? Anyone got a name for it? A definition? What does it mean to visualize something? Outside of the context of this discussion, when I say, my daughter visualized a unicorn, what am I saying she did? Sorry, can you speak? A symbolic, maybe symbolic. She might have visualized something that looked very similar to a unicorn. I mean, anything that is virtual is a symbol at some level, right? What is she doing, actually doing in her head when she visualizes a unicorn? She's forming a mental image of something, right? Or a vision of it. It might be more or less abstract. So another thing that we sometimes define to visualize as is to remember something or to imagine it, right? So this is from the American Heritage Dictionary. So how does that relate to what we're trying to do with data? To me, we're trying to make a visual representation of something that is abstract, that you can now picture this data. You know, and we're helping by showing you a picture of it, but it's in line with that original definition. And so here's another example of how powerful visualization can be. So does anyone remember when this is what you used to get when you needed directions? You can still get Google to give you a list of, right? Now, if you're driving, it takes a lot of time to visually parse where you are in this list of directions and move forward from them. So then we moved on to this kind of thing, which I would argue is often still the best that you get when you're using GPS, right? Sometimes there's a verbal overlay with this in it, but the maps, the Google Maps, the things like that that I use aren't much better than this, and this is decades old, okay? Now, here's the thing. So that's the route I'm taking, this gray route, okay? There are ways to show this information that are far more amenable to a quick glance than what we're used to. So this is a tool called Line Drive, which was actually available on the web for a while. I don't think it is anymore. And what it's doing is it's showing the key landmarks that you need in order to place yourself. And it's removing a lot of other visual clutter that might make it harder to follow what's going on. Now this is another tool that goes even further. And so what you're seeing here is that the visualization changes as you're driving. And so what it does is it kind of zooms in on the portion of the road you're in. It has an arrow indicating where you are in that, and it's actually increasing the amount of landmarks that are shown coming up soon versus the big picture of the whole drive. Sorry. Everyone still see? No. I think we just lost a screen, sorry. Oh, okay. Okay, so again, I think what this is illustrating is that there's a lot of subtle design decisions that you can go through in the course of designing a visualization. And in order to do it really well, you have to think about the context in which it's being used and what information people actually need. Because if you give them too much information, you make it harder to see what you need to see. And especially in a resource-constrained situation like driving, this can have a really big impact. So when you're planning a visualization, after you're convinced that your data is actually relevant to the question you're trying to answer and correct and all of the other things in those 4 C's, the next step for me is always to ask, what is the goal of this visualization? What am I trying to do for the person viewing it? What do they want to get out of looking at it? And related very closely to this, I ask myself, you can think about the person using a visualization as making essentially visual search queries, right? They have an idea that they come to this visualization, a question they want to answer. And so trying to understand what those queries are and how well they're supported is another really critical piece of designing the right visualization. And then once you have that, I copy. there's a ton of really great visualizations out of there, and there's also a ton of really bad ones. So you do have to be able to differentiate between the two, but there's no harm in taking something that works well and trying to imitate it when you're doing visual design work. And then finally, I repeatedly ask myself if I could make it simpler, because while you don't want to delete any crucial information, God forbid you fail to label your axes, for example, you do want to minimize the unnecessary information in a visualization. So those are the kinds of steps that I would argue you should be going through in designing a visualization. The kinds of things you need to think about in making visual queries are what is the visual system capable of processing? And you have to really bring a fresh eye to a visualization to see that. And so there's lots of texts out there that you can look at that have information about like how easy is it to differentiate 6 values if I use squares or circles or bars or other things like that. And it's pretty easy to go and look that stuff up. But the key thing to understand is that what you're trying to do is sort of leverage what we call Gestalt psychology, the understanding that we have today of how the visual system works and how you tend to group things when they look similar and separate them when they look different, how the location and shape of things is most easily interpreted. Another thing that you really need to think hard about in visualization is narrative. So this is a classic visualization that is discussed at length in, I think, the first Tufte book, which was one of the classic books on visualization. And what it's doing is it's showing what happened to Napoleon's army. And if you look closely, what we're seeing along the size of the army is the width of this chart. On the return is black, and the outgoing army is sort of bluish. And it's actually also mapped onto a real map in space. And then there's a sort of line chart at the bottom, which is helping to lay this out over time. And so at a glance, you can really kind of see how decimated the army was by the choices that were made about where to go, and the way in which winter and time affected this and location. So this is a visualization that's really trying to tell a story. Here's another visualization, sort of a very common kind that you might see. And I wanted to point this one out because I want to get back to the way in which we could draw erroneous conclusions from visualization. So the Napoleon one really supported us in drawing appropriate conclusions with the data. But here, this illustration is looking at hours spent studying versus score on an exam. So what can you draw? What kind of conclusion can you draw from this, if any? You need at least 40 hours to get a high score. In this, certainly for this data set, everybody who got a high score had at least 40 hours of studying. What's not visible in this chart is the low scoring students. So it really changes your interpretation of this data. Suddenly 40 hours isn't really telling you much, for example, right? Another thing that I would have said from this version is it's not clear that how much you study has much impact on how you do. But when you look at the whole picture, it suddenly seems as though, especially for students who don't have as easy a time with this exam, that studying does make a big difference, right? So this gets back to the fact that the visualization, choosing the right visualization alone doesn't allow you to draw the right conclusions. The sample in this case had a big impact as well. Okay, so, oops. I now want to talk about some of the visual effects that are important to consider, and I'd like to do it by going through a series of visualizations that are problematic. So this is a visualization showing the sales for different corporations that sell fast food. And what can you tell me about the sales of Burger King versus Starbucks at a glance? What's your impression there? Burger King clearly sells more. How much more would you say? Just estimate. 50% more, 100% more, 200% more? Who feels it's 200? Who thinks it's 100? Who thinks it's 50? Who has no opinion? Oh, come on. Who thinks it's 200? 300. Okay, great. So it turns out it is 9 times the area of Starbucks, that circle. Okay? And it's only 3 times the sales. So you were right, actually, with 300. I should have shouted out different numbers. My mistake. But what happens is that our visual system tends to favor area over height. So we tend not to interpret things by the differences in their height. So this is a visualization that tends to be misleading. And if I had said 100, 300, 900, maybe we would have gotten a better sense of how easily it is misinterpreted. So forgive me for that error. But that's a really important thing to know about how people process data. Another thing I actually dislike about this chart is it's full of what I would call chart junk. Things that are not really helping you to interpret the results here. It looks cool to use the logos, but they're not really helping you to get the information you want out of this. This is a different kind of error. So what this chart is showing is gun laws by state. And you can't see it on this projector, but each of the blocks coming out from the center is a different state. Okay? So the red ones are all ones that in 2012 voted Republican. The blue ones are all that in 2012 voted Democratic. And then you can see, for example, the orange circle shows you which states require a license to sell a gun. The gray ones, which you see are only on the top half in the blue states, require a background check by law. And the purple ones, which are also only in the blue states, require a permit to purchase. And the green ones are records kept on file. And then the blue are firearms banned from the workplace. So you can sort of pick any of these states, and it will give you a overall gun score if you roll over it with your mouse, and a murder rate. So it's an interesting visualization to explore. But I would argue it's not a great visualization of what they're trying to show. So what might you have done instead? And why is this not the right kind of visualization? Yes?
Probably have done like a table with different colors.
Yep, that's exactly what I would have done. The use of a round circular chart here kind of implies numeric data and maybe a pie chart or something like that. And it's not really giving you that. I think if you were to have a chart that you could sort, or that was sorted by a key variable, a table that was sorted by a key variable, you would much more easily be able to interpret these results. Here's another problematic visualization. So this is showing the drinking age in different provinces in Canada. And the Saskatchewan Party has ruled out lowering the drinking age. So you have to be 19 to have a drink versus 18 elsewhere. So what would you, does anyone notice anything strange about how this chart is designed? Say that again? Yeah, the y-axis has these floating point values on it, right? So this was probably the default produced by some program, and it makes no sense. I would actually argue it makes no sense to even have a chart like this, because there's only 2 ages, right, in the chart. So I'd be much more interested in like how many states have 19 as their age and how many have 18 as their age than I would be in seeing them laid out this way on this graph. So another example of a sort of non-standard design. Another thing that's not obvious in this design, but something to always look at for charts, is that the axis doesn't start at 0. So it's emphasizing the difference from 18 to 19 when actually, unless you're 18 in a state that makes you wait till you're 19, from most other distances, those 2 ages don't look all that different, right? So here's another example with a misleading axis. This is showing news magazine size over time. So there's several problems with this. So I just mentioned one of them that you should be seeing right away. What's wrong with the y-axis?
Starbucks.
It starts at 160, right? So it's, again, it's emphasizing difference by focusing in on it. Do you see anything unusual about the x-axis? Sorry? Yeah, that's right. So there's this like weird emphasis on the recent data over the older data as well that's not called out. So it's sort of a dishonest representation of this. So this is really weird to see. Now, if we actually show size over time without eliding some of the years and starting at 0, we see a very different picture of readership over time. So here, it looks like Time has way more readership than Newsweek, right? But when you look at it here, not only is it not that big a difference, but it looks like Time's doing worse than Newsweek in recent years. Here's a chart that I would argue, also, first of all, the y-axis also does not start at 0, right? It's also, in my opinion, overly complex. The legend is really far away from the line. So I don't know how many of you noticed before I pointed it out, even what this was. It's different states and their temperatures. Yes?
But sometimes you really need to make the y-axis to not start at 0 in order to show those differences.
So it's possible that there's a real reason to do that. And if you were going to do it, I would argue that you need to do something to highlight the fact that you did that. So one way that we see this is that sometimes people have a bar chart like that with a gap between them. Or sometimes it would be like a logarithmic scale. But you have to disclose that you're doing that if you do it so that people can interpret it better. OK. So here's a different version of average monthly temperature. So it's simplified. All of the data is still there if you want it. It's easier to see what cities are being represented here. And there's also actually additional information, even though it's easier to look at. It now shows season and freezing point on the axis, right? So you get a much clearer picture of the things that you might actually care about in a visual query from this chart than you do from this original one. So here's another really interesting one. This is a chart using what's called a tree map. So a tree map divides, typically you would see it face on, so it's flat, not three-dimensional. It divides a rectangle into boxes based on the size of the information in those boxes, and often there's a hierarchy there as well. So that a box that contains things that are within it in that hierarchy would be sized based on its children, and then their size based on their children, and so on. So there's like systems that'll map your file system based on the directory hierarchy that use this kind of visualization, which can very quickly allow you to identify big core dump files that you might want to delete if you're out of space, or movies, or whatever you tend to waste space on, right? So what they're showing here is causes of untimely death, and a couple are marked. Heart disease is marked on the upper right here. War causalities are marked as just 0.05% of the total life years lost annually. Natural disasters is the dark green. And then malaria over there is the yellow block on the left side. And this was something that the Gates Foundation was really pleased with because it showed that the number of people dying from communicable diseases, which I believe is everything in yellow, is still far too high. So they're arguing that these numbers need to come down. They are then saying we have the solutions, we're funding the work, and so on and so forth. But the key thing that is missing here is negative and positive change over time. So that if you can see here, the color, the richness of the color is a measure of change, and it goes from -3% to +3%. But when you look at this visualization, you don't see that difference at all. Even if you know it, it's hard to really grasp it, right? So in fact, what they're saying is true, but you don't get it from looking at the visualization. You have to read the subtext to get it. So here's an alternative visualization. And it's showing the percent change in the middle here. So anything on the left is a negative, is a reduction in life lost by this disease or process. And anything on the right is an increase. And it really highlights much more clearly what's going on. So cancer is basically not changing at all, for example. That's the top bar. It's the most common cause of death, and also the one that is causing the largest years of life lost, because so many people are going through it, right? And then you can look through this in more depth and sort of explore other things like this. It also has aggregated things. So different kinds of heart disease, which is the second bar, by the way, are all aggregated together, rather than keeping too many things that people aren't going to necessarily want to differentiate separate. Here's another one that I think is problematic. So this is the customer account tracking across many different regions. So why would you want to track customer accounts across regions? What's the obvious reason you would do that? What's the goal of the person viewing this? Well, if you wanted to, if you wanted to change a marketing strategy in a specific region, it's not clear why you need the other ones. Okay, anyone else want to?
You would want to know where that kind of product sells well.
So you want to know where it's doing well?
Yeah, so you have a number of products and you want to split it into regions.
Maybe you want to split. Okay. All of these things presume a underlying goal that is even sort of simpler than what you guys are saying, I believe, which is that you want to compare. Does that make sense? You want to compare. So how well does this visualization allow you to compare? How quickly can you find the best performing, the worst performing, what the average is, those kinds of things? It's okay. It helps that there's only a small number on it. But really, I would argue that even if you can figure out what's best performing, how many people can tell me which region is best performing? Shout it out as soon as you've got it. Yeah, okay, see, so it takes, right, the labels are nowhere near the bars, right? So that's an example of why this is hard to deal with. It's difficult to compare any two given regions. So if I said, how is region 3 doing versus region 4? It's going to take you a minute to get that out of this chart, right? So all of the obvious visual queries that we might want to ask, not well supported here. So here's a variation on this chart that I would argue is improved. It's much less cluttered. It's sorted. The labels are really clear, right? So we see a big improvement if we go from this kind of visualization to this one in supporting the kinds of queries that we presume you would want to be able to do with this data. Here's another one that I think is really interesting. So this is job losses per month. So let's see what the axes say. On the left, you have job loss. So the 0 line is what most things come down from. The very left thing is actually a job gain. And then across the top, we have years. And we see it split into red and blue based on which administration was in control. So the title of this chart is US job losses per month. But I would argue that it's, even if that's what it claims to be showing you, it's actually showing you something very different. So what do you think? Who could you imagine made this chart, and what do you think they were trying to accomplish with it? It could be, right, so a politician, let's say, who is favorable towards Obama. And what are they trying to get you to see when you look at it?
Brighter future.
A brighter future, yeah, a change that's happened over time, right, that seems to be different for one group versus another. So this is showing a change in the data. It doesn't actually show you the present state of the data very clearly. It's showing you what's happened over time. Most importantly, what it's not showing you is the actual unemployment rate, right? That's not shown at all here. It's just showing the monthly change in unemployment. So it's not really doing what it promises to. So we can think about changing this, right? So this is actually showing that unemployment increased over time and has not returned to its December 2000 levels. Because what's actually happening here is that the job losses have slowed, but they're not gaining, right? So this is a cumulative thing. I think it's really powerful to see the difference in the conclusion you draw from one chart versus the other, right? I would argue that what you might actually want to look at is something like this. So this is cumulative job loss over the first year of Obama's presidency and the last year of Bush's presidency. And you can see that Obama's are actually worse than Bush's at the beginning, but they're leveling off, whereas the other one was kind of growing exponentially. So this is maybe an intermediate version that is allowing you to make the comparison that was really implicit in both of these, right? What they're really asking us to do is compare Bush and Obama, clearly, right? But this is the only chart that actually facilitates that comparison. And it tells a story that is a little bit in between the extreme stories that the other two charts told. So here's another view, which includes those who were already unemployed before the time period of the chart started. And so that's going back to the original thing of just total unemployment rather than percent. So there's many variations on how you can show this data. And one of the things to realize is that they're all following reasonable rules for how you show data. They're disclosing their axes. They're all generated going from 0 up or down. So there's nothing on the surface that's horribly wrong with any of these charts, yet they are taking a stance. They are not value neutral, and they are influencing what you conclude. Here's a final one, which is showing employment since the recession. And it's overlaid different decades or portions of decades. And when you look at this, the interesting thing here is this line is 2007 to present. I forget what present was when this chart was generated, right? Versus all of these other ones. So there are so many ways to view this data. And I can't give you a recipe for how to visualize data correctly, but I hope I can inspire you to really think hard about what people are going to conclude from the data you show. And this sequence of charts goes all the way back to what we were saying about causality and the way in which, right, people are going to jump to these kinds of conclusions from what you show them. So I wanted to switch tacks a little bit and talk about the importance of interactivity in visualization and what happens when we support exploration instead of just supporting viewing something. And I'm sorry that I'm having trouble finding my mouse here. Where is it?
We'll demonstrate Kinetica, a prototype system we have developed to explore how physical models can improve data visualization. Imagine you were interested in identifying trends among survivors and victims of a Titanic shipwreck. You find a data set and load it into Kinetica. Now you use the array of physics-based tools in Kinetica to explore the data and find patterns. You begin exploring the domain and range of different dimensions of data. You choose survival as it divides the data nicely into two groups. You are curious how gender and cabin class relate to survival, so you choose a force-based scatter plot and draw it onto the sandbox using 2 fingers. The points immediately fill in attraction to their proper place in the chart. You notice an interesting trend. The survivors marked in yellow. This means that more men, the top row, died than women. Moreover, you note that there are more survivors in the more expensive cabins towards the left of the chart. Now you wonder if this trend holds for just the children on board the ship. You select the wall tool and choose to filter passengers by 15 years of age or younger. Using the wall, you drag it across the scatter plot to filter points as you go, finally tapping it to turn it into a permanent barrier. Since the points you just separated still feel a pull towards their positions in the scatter plot, they separate into male and female groups. From this you can see that there are still many deaths among the children, and the male-female trend you noticed earlier seems to carry over into the smaller group. Kinetica provides a rich set of tools for interacting with data. This means that there's often more than one way to answer a question. For instance, instead of pulling a wall across points to filter out younger passengers, we can use a lens to highlight them. Instead, we might also exclude the older passengers from a region of space. By combining Kinetica's tools, users can quickly explore multiple dimensions of data. Here a user filters passengers by age, sorts them by gender, colors by cabin class, And finally, identifies those who survive using a lens. Thanks for watching our demonstration of Kinetica. We hope that you found these physics-based tools for multivariate data visualization as interesting and exciting as we do.
So this is now a startup run by the PhD student who came up with this idea, I believe. So there's a lot to say about interactive visualization. We're running a little short on time, so rather than talking more about that, I just wanted to touch on one other topic, which I think is really relevant to what you're doing in this class, which is how you deal with big data when visualizing information. And I think that the issue with big data, besides just the speed issues and sort of processing time issues involved, is also how do you allow people to draw reasonable conclusions. So this is the frequency of the mention of 5 US presidents between 1984 and 2009 in news articles. And it also indicates the weighting of the stories. Was it on a front page or further back? So there's a huge amount of data being shown here. And one of the things I want to point out about this visualization is that he's not using every pixel on the screen, right? So this J.R. Thorpe is what he calls a data artist, is what he calls himself. And he could have said, well, there's so much data, I should use every single pixel and make sure that every data point that I can fit on the screen fits on it. But in fact, what he's chosen to do here is to do something that's a lot less busy in order to emphasize a few key things about the data, right? And you can then imagine, if this is interactive, that you can zoom in and get more information. So in case it's not easily visible, what we see here is that all of the years in this data are in a circle here. And then the color, of course, indicates party. And you can see up here he's sort of labeled these, so you can roll over them and highlight one person versus another. So I think one of the take-homes for big data is that these kinds of visualizations that don't show every detail are really important. This is another one. It's a bar chart, so he's packed a lot more into it. But what he's really showing here is it's a visualization of the frequency of occurrence of the word sex in New York Times articles. And he's chosen to use machine learning to extract keywords for articles and sort of place them above the article. And so if you could interact with this and zoom in a little bit further, you'd be able to see, I'm sorry, the projector's not showing it, some of the words that were sort of prominently being used in articles at certain times. And so that's not the word sex, it's the word that's sort of most important in the article. So maybe it would be Monica Lewinsky at a certain time or something like that, right? So it gives you a sense of the data. Another thing that is often done with large data sets is to map them in space. So these previous visualizations were really mapping the data in time. This one is mapping it in space. And what you're seeing here is census data of race in Los Angeles. And what I like about this visualization, and note that it's a static visualization, but it's showing 2 key points in time, is that it's highlighting something that's changing. So this visualization, you can certainly dig into it and draw what conclusions you want from it, but he has chosen a very specific visual query to emphasize. So what's going on in this query? We're seeing highlighted specific neighborhoods and how they are changing over time, and how the prevalence or the degree to which they are a mixture of races or any particular race is changing with time. So this gets back to, it doesn't matter how complex or large the data set is, you have to think about how to zoom in on the specific kinds of questions or a specific question for the person viewing it in order for it to be an effective visualization. We're almost out of time. This is highlighting the way in which people are moving into cities. So sort of another nice example, very pertinent to the recent election, right? And I'm going to just skip over these, are just examples of techniques you can use. I guess I want to add zooming to the list of things we're discussing. So this is a visualization of Wikipedian activity. So what's being shown here is logos taken from the Wikipedia pages and dots, which represent the amount of activity associated with that page. So you can see, like right there, there's this really big dot. What's going on there is a question mark. And so you have to zoom in to get that. But these large circles represent like edit wars, so they're controversial articles. And so this ability to zoom in lets you then further explore that kind of thing. We're going to skip over distortion. I knew I had more slides than we could fit, but I wanted to throw up some things that you can look at afterwards if you're interested. So what I'd rather do than go into yet another domain is just talk about sort of the summary of the key concepts that I hope you got from this lecture. So make use of pixels. I say every pixel here, but sometimes what you need to use pixels for is blank space. So it's important to think about how you're using every pixel, right? Using color and location to break up the data and really to support visual queries. Zooming is a really good way to give people access to more detail, but the zoomed out version needs to tell a story that will engage people and answer their questions. And I believe that the next generation of interfaces are going to be interactive, and that can support you as a data scientist, it can support the end user and everyone in between. Finally, yeah, I think I would like to take questions and end here. Yes?
So at the beginning you said that you have to treat your data, you have to figure out if your data is going to trust on it or not. But in reality, you always don't have good data. You always have like partial data or biased data.
You never have complete data, almost never, yeah.
So how do you go around that and keep working or consider the fact that this data is incomplete or biased?
Yeah. So if you're talking about as the data scientist, how do you deal with that? I would argue that the really important thing to do is to identify the sources of bias in the data. So a really classic example is when people go on Twitter and think that because there's so much data in the Twitter fire hose, it's representative of the US or the world population, right? And then they draw conclusions that make no sense when if you really care about representing the complete population in a region. So you cannot fix Twitter, right? It's never going to have those other people in it, but you can go into your analysis understanding what it's lacking. And so you have to be a detective. That's the first thing you have to do in order to understand what's going on with your data and what is valid to conclude from it or even to say about it and what is not valid. The second piece is what do you show the end user? And this is where accountability to me is so critical, because accountability is a thread that goes from whoever collected the data through you as the data scientist, ideally all the way to the user. And so in a sense, what I'm saying is that your visualization needs to help the user understand its own limitations if it's really going to be honest to the data. And I think it's really important to take the time to put information in your visualization that might affect how people interpret it. So some of the series of charts we looked at about the job losses under Obama and Bush were all valid ways to represent that data, but only if they are a little bit better about self-disclosing what the viewpoint of and goals of the person creating the chart were. And now we're not even necessarily dealing with bias data there, but I still would argue that better self-documentation is critical to those charts being interpreted properly. If we go all the way back to the student debt data, they were really not complete in documenting the sources of bias in that data. And not everyone who views those charts is really going to read the details, but I think you're obligated to at least put them there and say, well, we didn't count people who weren't paying off their debt in this thing, right? And highlighting key facts about the data set alongside the visualization. Yes?
It inherently has a bias because I came up with that visualization. So how do you include it?
Yeah, so you said there's always a bias in any visualization because there's interpretation going on. You know, I mean, this is at some point an age-old problem. You know, we have philosophers of science that argue that no science is value-free. And if you've already accepted that, you're well along the way to doing the right thing for the people who are viewing your data. There is no way around that. Yes? Yeah. Sorry? My course in the spring? We kind of go through the whole pipeline from collecting data all the way up to creating interfaces that let people engage with the data. And along the way, there's a series of what I call bites, which are exercises where you kind of do a piece of this. And it always ends up as a Google App Spot thing, so it's a portfolio item. And then there's a final project that takes up the last month or more of the semester. It's called Interactive Data Science. And it's 9 a.m., I think Tuesday, Thursday, in the spring. So
So when there's so many options for visualizations, how do we exactly decide, like, for our data which visualization is correct? You know, which is the ideal one?
Yeah, that's a really hard question to answer. You know, one thing you can do is actually test it on people, and even showing a sketch of it to somebody and asking them what they got out of it is a really good way to make a start towards that. But to me, I think that if you explicitly write down what question you're trying to answer and why, and sort of work through from there what I call the data pipeline of, like, how does my data match the question, how does my visualization, is there a chain from the question I'm trying to answer to the visualization I'm showing, you will uncover the logical errors that you might otherwise not in whether or not you're showing what you think you are. So I think just the practice of looking at your data and asking this question about it will improve things a lot over what you would get otherwise. Thank you all.